Hello, judges. My name is Lata here, and this is Project Rapido Rescue Ops, a multi-agent rapid disaster intelligence architecture and a high-speed knowledge graph-driven injection pipeline that I am going to present today for the Agents for Good capstone track. This is a humanitarian knowledge warehouse. The project integrates a cloud-based data layer with an agent orchestration layer and containerizes our Python execution pipeline. We utilize Google AI Studio's build mode to interface directly with the underlying anti-gravity coding agent, harness. This playground allows us to against a, prototype agent behaviors and system instructions before compiling our final dataset structures. During humanitarian crises, normally the command centers are overwhelmed with messages from field agents, and the relational databases get choked up. These run out of memory, and the cloud hardware usually causes memory crashes. This tool resolves this by acting as an high-speed, low-memory semantic knowledge engine. Now moving on to the technical architecture and orchestration. As we look at the architecture, the pipeline divides natural language processes parsing across four distinct agent layers. These are the triage, the geoparsing, the warehouse, and the command and control assistant nodes. The triage classifies the incoming intents, geoparsing agent isolates the geographic markers, warehouse janitor ensures the data integrity and security, and the command and control assistant node provides a zero hallucination interactive terminal. Now, coming on to the other portions of it, these are the libraries that have been defined. And you will see that we come to a very important portion. And this architecture, we have engineered a strict low RAM memory management strategy by injecting aggressive garbage collection routines, especially between our cell operations. We completely bypassed the 16 GB container RAM bottleneck without requiring any expensive compute upgrades. These are the libraries that are defined in the code, and you will see the security aspects of it being taken care of, the data schemas that are defined, and the classes that are also defined and processed. And we also see that we also come to the major portion where we have complete closed loop system which is getting executed, and it generates an output where it talks about the various nodes and the command nodes and the affected victims, the status, and the hazards. Coming on to the plotting part of it, that is a graphical output part of it, you can see that the graph generates the various nodes with the centers, command centers, and some of these are unspecified resource. Say, for example, this blue and green one, which shows that they are out of boundary, either the geographical boundary, and this abstraction allows the network model to continuously track the critical victim needs and the resource allocations without requiring precise administrative mapping or any other problems. Coming down to the last part of it, we have the course evaluation key concepts demonstration that we have gathered. The key concepts that are covered in this tool is the multi-agent system, that is the ADK, agent skills in the form of CLI, and the security features. Now you can see the output, and that gets outputted to a submission.csv, which takes care of the requirements, the competition requirements. So that is all that I've got for this presentation today. And thank you for your time. And this rescue hops has been generated under 1 minute, and the execution time is almost very good in terms of the processing. Thank you so much.